Welcome to part 2 of the Aftertreatment ISX 871. Tonight we're going to talk about the diesel particulate filter, so let's get going. Here we go. This is about as bad as it gets. This guy had some major engine problems, which we took care of. We're going to swing around to the front where you'll see he had antifreeze going into it, that red ELC, that's why the red staining there and the plugging and the white clumping. We fixed them up. This is what a new after treatment element looks like. This one's setting up on top of the outlet can. There's the face of it. It's okay if there's writing on it. It's okay if it's white or pink. It's okay if there's burn marks where the welding is on the edges. On the top left, the pink, that's what a new element from Cummins Recon might look like. That's fine. The second one down is what you see in the newer trucks like the 2350s and 2450s. They've gone to a different substrate. I think it's much tougher than the other was. Number 5, which is yellow, is the DPF inlet. It has a lot of oil ash on it. If it cleans up, if you have it cleaned and it cleans up okay and it passes, you could reuse that. Number 4, red's got a crack right across the face of it. You can see that vertical crack. If it's cracked on the face on the outlet, the inside's really bad. And number 3 on the bottom, that's really bad. That's the outlet after we pulled it out, and there's soot staining all over the face of it because the cells are all broken internally. This is an illustration of what a good DPF would look like. These are the individual cells, and you can see on the end, they're blocked on one end, open on the other. Those small lines on the sides of walls are the porosity that the gas goes through, but the soot can't. So that DPF we just looked at where the outlet was all soot stained, that's what the cells in this would look like. And you can see on the left, that would be soot particles coming in, but the cell walls are cracked, so the soot particles go right on down and out the other end. Remember, in a DPF, on both ends, there's open cells and there's closed cells. So if you lay the DPF down, on the left end, all the open cells, on the right end, those cells are closed. On the right, all the open cells, on the left side, they're closed. And that makes the gas go in and exchange through the porous walls. That's how the soot is caught. Here, because of the big cracks, the soot goes right on out. So this is called breached. So we just looked at those cracked cells. Let's see what happens that those cells get cracked like that. So you're running along, and for some reason the engine's making more soot than it's supposed to make. And what happens is the unit's not in a regen, but the exhaust temperatures are hot enough for it to start cleaning itself. So the DOC's warming up because soot touches the DOC and it's fuel, partially burned fuel, and it burns. So the DOC starts making heat when the engine's running smoky. And then the DPF is loading up quickly with soot. So the system, once it reaches about 850 to 900 degrees, that soot starts to ignite. When you get up to about 1040, it's ready to go. That soot's ready to burn. It's hot enough. And it will take off, and the engine will try to control the temperature by doing some things with the turbo to cool the exhaust down, to try to cut the oxygen back there. But it happens pretty fast. So I've seen in the fault snapshots, I saw one time 1490 degrees. And if it gets that hot, you're going to have cracked cells happen. So that was a little graph from a spreadsheet that I had that shows exactly what thermal runaway is. And thermal runaway in the after treatment is when the DPF gets so loaded up with soot and then it gets hot enough for the soot to burn, that the burn can't be controlled, and the inside temperatures get so hot. I have seen them, after we got them back, we cut the DPF in half with a big saw, and inside it just looks like a big wasp nest of cooked glass. The outside edges look good, but they're all cracked, and the inside just a melted blob like a football. So that's why you need to understand what you're looking at when you're inspecting the DPF, and that's why you need to watch those fault codes, because the engine will log faults for exhaust over temperature when this first starts, and if you catch them early, sometimes you can stop from having a very expensive repair. Okay, what you need to know. On the ISX 871, the 4 fault codes that relate to the DPF are 2639, and that's a fault code that doesn't turn a light on. The ECM has to have a fault code go active for the software to do something or take an action. So if they want the engine to go into the mode where it will passively regen the aftertreatment by heating it up, and by the way, you usually got to be on the freeway, or I should say going over 45 miles an hour consistently for about 15 minutes loaded to get enough heat in the exhaust system for it to do a passive regen. So if the engine's running properly, it might take a week of running before there's enough soot in there to change the pressure differential across that element enough where 2639 will go active. Remember, it doesn't drive a dash light. The driver has no idea this is happening. The turbo will do a little change. The fueling will change a little bit. He won't lose any power. Some guys can notice the way the engine feels that it's in a regen. The newer engines, they can't even tell really. They've got the software down to a science. But on the older 871s, it'll do the change, and it'll start heating the back up, and then just the hot air from working and the timing changes can get that soot up to about 850, 900 degrees, and it'll start to burn. It's slow, but it burns. Does it do a complete burn? No, it doesn't do a complete burn in there, but it burns out almost all of it. So that's the passive. Then you've got 1921. Let's say the driver's in town for 3 weeks. He never gets on the freeway, stop and go. The engine hasn't had a chance to do a passive regen, even though if you hooked up to it, you would see 2639 is active. When I say hooked up to it, I mean with the scanner. We used Cummins Insight. You'd see that fault's active. But not a problem, because it just means the soot load's higher than it should be. So as he's driving around in the city, the soot load's going higher and higher. When the pressure gets high enough, it's going to turn on the light on the dash that tells him to do a stationary regen. It's usually a blue light, and he'll push that button, and he's got to be parked. There's some things that you have to do. We'll talk about that in another video. He'll start the stationary regen. In about an hour, it'll clean itself. When he does that, with 1921 active, if everything's working properly, in about an hour, it will be able to completely clean the after treatment, and he's ready to go again. If something's wrong, or if he chooses not to push the button and he's driving and driving and driving, eventually it will get so plugged that 1922 will go active. Once 1922 goes active, it's in a severe derate, and pretty much he's done. He's not going to be able to pull, and his RPMs are going to be really lackluster, and he's got to go to a shop. And what has to happen then is the after treatment has to come out, has to be cleaned or replaced. Then you have to go in with software and do what's called cleaning reset or a maintenance reset if you change the filter. That'll take 1922 inactive, and 1921 will be active. Now, even if you put a brand new filter in there, do the resets, 1921 will still be active. 1921 means the soot load is too high. But we know there's no soot in the filter, right? Because we just put a new one in. Why does that happen? It's how the software is built, and you have to do that full stationary regen using Insight or some other software. And once it finishes that full regen, the software will go, okay, now I really do believe the soot load is 0 where it belongs, and 1921 will go inactive and you can clear it. So on the very early 871s, they had 1922 and or 1981. Either of those faults were bad news. You had to pull the DPF out, do resets and stationary regens with software. 1921, that's the driver's last chance or the mechanic's last chance to do a regen without having to pull anything apart. If the thing's really sooted up, sometimes when you start the regen, it will get too hot too fast and it'll kick itself out of a regen, and you'll look and see and the temperature just went right back down. It's trying to save the after treatment. It is semi-smart. And then you wait about 20 minutes and then you put it back in a regen. It'll go back up, get it hot again. And the worst I saw, I had to do that twice before it finally made it through. And then we pulled the after treatment out and had it cleaned and put it back in. Today, we're talking about cleaning. Today, we really don't do that. We just exchange them because our luck with getting them cleaned and then having a full service life wasn't that good. Most of the time, we only got about 50% of the expected service life out of the clean filter. So by the time you add up the trucks out of service, you got to buy gaskets and clamps. You got to pay $500 to get it cleaned. You lost a couple grand. A filter's between $900 and $1,600. So it wasn't worth cleaning them for us. So we just exchange them now. Not to say that you have to or should. So that's the 871 we just finished talking about. And those are the only faults related to that filter. And again, what drives that regen process is that differential pressure sensor that measures the restriction across that diesel particulate filter. Thanks for joining me, and we'll see you for part 3. If you have any questions, ask them. And when I start part 3, I'll address the questions that you put up for part 2, or if they're quick, I'll answer them with text. Thanks again.